Assalamualaikum warahmatullahi wabarakatuh and good morning to everyone. Okay, so today we are going to discuss the last final part of our lecture for topic 5 with the topic of vectors specifically in application of vectors in geometry. Okay, so I do hope that all of you ready with your lecture notes with your hand right now. Okay, so for today, we are going to find the equation of a plane. Okay, in vector form and Cartesian form, determine the angle between two planes and line and a plane, and determine the point of intersection between line and a plane. Okay, so first one here. Okay, so a plane in 3D space is uniquely determined if a plane in a space has a normal vector of n and pass through the point of A, okay? Or in the number 2, a plane passes through 3 given points. Okay, just imagine that, let's say, as we know that we are talking about a vector in 3 dimensions with with a x-axis, y, and z-axis. Okay, and then given to us 3 points. So let's say, just imagine that there is a coordinate of A here. Okay, and this is we call the position of the plane. So then we are going to find out the normal of the vector. Okay, because we call the normal of vector. Of course, we know that when we mention about the normal, meaning the angle between this plane, okay, there is a coordinate of A, and there is a vector which is normal form the 90-degree angle between the straight line and the plane. Okay, so we can form the equation of the plane. Okay, so with this point of A, for example, on this plane, and then there is a normal vector straight line passing through meaning just imagine that if this we call the position of the plane, and then the pen moving from down passing through the plane. Okay, so here the plane with the coordinate of A and the normal passing through. As a normal, we know that it form the 90-degree angle between the line on the plane and also the normal. Okay, so just imagine that if I make a line, we call a vector here. As you can see, the vector of A and then the normal of n. Okay, and then the second part is a plane passing through. Okay, a plane passing through 3 given points. Okay, so for example, okay, look at this one here now. We get A, B, and C, and this is the position of the plane. Okay, so then we are going to find out the normal vector of this plane when we given we call the point of A, B, and C by using the cross product, and it will give you a normal vector to the plane. Okay. Next, so given a plane space has normal vector of n, okay, the normal, okay, given here, and pass through the fixed point of A, let R be the any point on the plane since n is a perpendicular. Perpendicular means that it forms the 90-degree from the plane, okay, to the plane, then n is perpendicular to the AR. Okay, so imagine that this is a plane something what we call a surface something like this, okay, a surface something like this, and there is a coordinate of A, B, and C, or might be a vector of A here. Okay, so then AR equal to 0. AR, as we know that just imagine that in this vector there's an origin point of O, 0, 0, and 0. So there's a vector from O to A and A to B equal to a vector of OR. Okay, so a vector of OA plus AR, according to this picture here, A and R equal to a vector of OR. So then vector of AR equal to vector of OR minus OA. Okay, so then from vector of AR equal to vector of OR minus OA, multiplied with the normal of n. So this is the normal here. This is the vector of the normal here. And then this is a vector of A and this is a vector of R. So then we multiply, expand it, and then make it in form of R dot, we call the vector of R multiplied, not multiplied, the dot product with the vector of n normal equal to A dot n. Okay, so we simplified this one here. We call R dot n equal to P, where R equal to any vectors. Okay, the n is a normal vector that form the 90 degree from the plane. Okay, and then vector equation of plane. Okay, as you see on the screen here now. Okay, so this is in the form of Cartesian equation. This is a vector equation of the plane, and then this in the form of Cartesian equation. So find the vector equation of plane which contains the point of 2, -3, and 5 and perpendicular to this line. Okay, so in this question, just imagine that there is a plane here. Okay, a plane, something like this, a surface. Okay, and there might be this we call z-axis, y-axis, and x-axis, something like that. Okay, so okay, in this topic you need to be good in imagining the picture of that question here. Okay, so because even though let's say this is an x, y, and z, might be the we call the coordinate of the plane with something like this, and it form a plane which is not exactly we call parallel to the any x, y, or z axis. Okay, it can be in any condition or position. Okay, so now back to this question here. Find the equation of the plane. Okay, vector equation of plane which contains the point of -2, 3, and 5. So -2, 3, and 5. If I put this as a vector of what we call a coordinate of P. Okay, the coordinate of P here, and then perpendicular. Perpendicular means that it's form a 90 degree to the line of this one. Equation of plane R equal to A plus T with a vector of V. So this vector of V is our direction vector. This is our reference. So then we look at this one here, 3, -1, and 2. So then, okay, if I put a P here, this is what we call the coordinate of P, and the graph, okay, the line from down here passing through this point and that here, and then this, okay, this line and this we call plane form the 90 degree, okay, each other then. So now for this case, a vector equation of a plane, okay, of a plane where R dot n equal to A dot n. Okay, so that N class. Let's say this is the to the line of L, and this line of L form the 90 degree passing through this plane. So just imagine that this line of L is also the normal of the plane. Okay, the vector normal to the plane, and this is our reference for the straight line. Okay, so in this case, where N equal to 3, -1, and 2, and passing through the point of -2, 3, and -5. So because we substitute with the value of A here, I think that it's better for me to change this point, label this as an A, the point of A. Okay, point of A here. So then A equal to -2, 3, and 5. So then A dot N, okay, A dot N equal to, okay, dot scalar product, meaning that the element in I multiplied with the I here, so 3 times -2 plus -1 multiplied with 3 plus with 2 multiplied with 5. Okay, so then -6, -1 times 3 minus 3, 2 times 5 equal to 10. So then -6 minus 3, -9 plus 10 equal to 1. So then R dot N, where N is 3, -1, and 2. 3, -1, and 2 equal to 1. There you go. Okay. Okay, next example. Find the vector and the Cartesian equation of plane which contains the point of A, B, and C. Okay, again, just imagine that this is a we call the condition or position of the plane, where it might be this z-axis, y-axis, and x-axis. Okay, it can be in any position here. Now, the vector we call is contained the coordinate of A, B, and C, and then we are going to form the new vector of N, the normal, passing through this we call plane. It might be here in the position of A, or might be B, or C. It can be in any these three position. Okay, these 3 points. How? Okay, now, okay, if I sketch the plane here, and then this is A, B, and C. So there is a vector of AB and AC. Okay, this one here, I make this one here as a B, and also here is C. A, B, and C. Okay. A, B, and C. Okay, so now we are going to form a new normal vector of N, which is perpendicular to the vectors of AB and vector of AC. Okay, here now we are trying to form the vector of N using the right hand rule. Okay, so if I use the my right hand side, okay, it's going to be something like this. Look at this one here. Just imagine that this is from the vector of AB, and we turn it, while you look at this, what you call the thumbs, what you call pointing up here, and from AB to AC. AB to AC. So the movement of my fingers just now from AB to AC and the thumbs is pointing up here. Okay, so then for this case, OA plus AB equal to OB. Using the equation of position vector from any point of A to A, from O, origin point, to A, O to B, O to C. Okay, so then AB equal to OB minus OA. So from A to B, we just imagine that if the coordinate of B here, 3, 1, 1, minus the earliest of the coordinate of A. So from A to B, then we can just simply put it as a coordinate of B minus the coordinate of A. So here now, 3 minus negative 1. 3 minus negative 1, 3 plus 1 equal to 4. 1 minus 2 equal to negative 1. And 1 minus 0 equal to 1. And what about another one here? From O to A, from any point of 0 here to A to C equal to O to C. So then AC equal to OC minus OA. Okay, again, from A to C, so just imagine that is a coordinate of C minus A. So 1 minus negative 1. 1 minus negative become positive then. So 1 plus 1 equal to 2. 0 minus 2 equal to negative 2. 3 minus 0 equal to 3. Okay. So you may write this in this form, or actually that is 4i minus j plus k, or 2i minus 2j plus 3k. Either one is either this or this. It's all up to you then. Okay, now we are going to find the vector of n. Vector of n equal to a vector of AB cross AC. Okay, vector of AB cross AC. Okay, so then it is now, okay, with the I, J, and K, we get 4, negative 1, and 1. 4, negative 1, and 1. And 2, negative 2, 3. Okay, so I think that all of you still remember on how we're going to solve this, because I already explained this to you in the earliest of the lecture in part 1 and part 2. Okay, so then I straightly give you the answers for this one. The process of this is going to be 4, negative 1, 1, 2, negative 2, 3, and we get negative I minus 10j minus 6k. Okay, so this straight line of n equal to negative 1, negative 10, negative 6. So then the vector equation equal to, okay, a vector equation which is r dot n equal to a dot n. Okay, so then a, for this case, we're taking the a, okay, for this one here, assuming that this is the coordinate of a from origin point of O to A, okay, from O to A, which is negative 1, 2, and 0. So then a dot n equal to negative 1 to 0 dot product with n, which is negative 1, negative 10, negative 6. Okay, negative 1 times negative 1 equal to 1. 2 times negative 10 equal to negative 20. And 0, okay, negative 1 to 0. So then plus with 0 times negative 6 equal to 0. So it is negative 19. Okay, this is a calculation for A dot n. So now R equal to R dot n, which is n equal to negative 1, negative 10, and negative 6 equal to negative 19. Okay, or R dot 1, 10, and 6 equal to 19. This is negative 19, so multiply with negative here, so we got a 19 here. Okay, so then next, by substituting R equal to xi plus yj plus zk, so R dot n, which is n, okay, R dot n equal to, we got just now the normal is negative 1, negative 10, negative 6. Okay, negative 1, negative 10, negative 6, where n equal to negative 1, negative 10, and negative 6. So then multiply with this one here, negative 1 multiply with x, negative x. And then negative 10 times y, negative 10y. And negative 6 times z minus 6, z equal to negative 19. So then x plus 10y plus 6z equal to 19. Okay, I'm sorry for this one. It has something to do with technically with the pen and that we call the material here. Okay, so that's it. Next one. Find the vector equation of a plane which contains the line of L1 and L2. Okay. So now class, okay, now just imagine that there is a line in this we call surface. There is a line of L1 and L2. Okay, so if I make it longer here, okay, so from L1 and L2, okay, there is a line of intersect between these two lines, L1 and L2, intersect here. And from here, we are going to find out the normal vector between these two straight line 1 and straight line L2. So we're going to form that new straight, we call new normal, where we call 90 degree from the, from the plane, and this one, okay, from here, we're going to find out the equation of the plane. Okay, so then, again, if I sketch it here, okay, there's a line of L1 and there's a line of L2. Okay, so class, between this L1 and L2, this is our reference. This is our direction vector. This is our reference. This one here, V1 and V2. So from here, we are going to find out the normal plane, normal vector of n, which is from the 90 degree to the L1 and 90 degree to L2. Okay, so now the normal vector n equal to, so we are going to come up with cross product with the I, J, and K. We got 1, 3, negative 3, 1, 2, negative 4. Okay, 1, 3, negative 3, 1, 2, 4. So, I'm not, as I said that in this video, I'm not going to explain the process of this because it will be explained in the earliest of lecture part 2, part 1, or part 3 Find out yourself. Okay. So now this one is gonna give you negative 6i plus j minus k. And then class, this line is on the plane. Okay, it has a where we call the coordinate of A, for example, here and here. So you can choose any of this where we call coordinate of A is either from L1 or L2, because this line, okay, L1 and L2 is on the surface of the plane, meaning there is a coordinate of A for this line or A here for this line. You may just set for yourself here. So if I choose this one, okay, I choose this one easier. Okay, so then R dot n with negative 6, negative a positive 1 and negative 1 equal to A 1, 1 and 1. This one here 1, I, J and K dot product with negative 6, 1 and negative 1. Okay, 1 times negative 6 equal to negative 6, 1 times 1 equal to 1, and 1 times negative 1 minus 1. Negative 6 minus 1, negative 7 plus 1 equal to negative 6. Okay, so then R dot n equal to negative 6, which is R equal to, let's say R equal to xi plus y, j plus z, k, and then the n equal to negative 6, 1 and negative 1. So then negative 6x plus y, okay, negative 6i plus y minus z equal to negative 6. There you go. Okay, now when given to you, okay, like to find out the angle between two planes, given two planes of S1 and SN2, S2 here. Just imagine that this is one of the plane. Okay, this is one of the plane, and this is another plane. Okay, that this plane intersects something like this. Okay, how can I say this one? Okay, this one and this. Okay, so there is an angle between these two planes. This one first, this the first, and then the second one here. So there is an angle between these two planes. Okay, then the angle between two planes is given by, okay, now class, between these two planes, the equation of plane contains the equation of plane, not this one here, okay, never mind. The equation of plane is R dot n equal to A dot n. We have the normal, so there's a normal for this plane. Okay, and then let's say there is another plane here, and it also has a normal. So n1 and n2, so they intersect here, and this is the angle that we like to find out. Represent the angle between these two plane, we call S1 and S2. Okay, where theta is an acute angle. So find the angle between two planes here. Okay, what is the equation of plane just now? This one. Okay, so we rewrite we call the equation of plane theta equal to cos n1 dot n2 divided by absolute values of n1 multiplied with absolute values of n2. Okay, now from this case, S1, okay, 3x minus 2y plus z equal to 5. It is R dot n, where n is 3, negative 2, and 1. 3, negative 2, and 1 here equal to A dot n, which is equal to 5. So meaning here, the n1 is for this equation of S1 here, which is 3, negative 2, and 1. And 2 equal to 3, 3, negative 1. There you go. Okay, so the first thing is we are going to find out what is absolute values of n1 here and absolute values modulus of n2. So then, modulus absolute values of n1 equal to square root of, okay, we got 3, negative 2, and 1. 3 square plus negative 2 square plus 1 square. Okay, square root of 3 square is 9, square root of 2 is negative 2 square equal to 4, plus 1 square is 1. So 9 plus 4 is 13, plus 1, 14. And absolute values for n2, square root of 3, 3, negative 1, 3 square plus 3 square plus negative 1 square. Okay, so then it is 9 plus 9 plus 1 equal to square root of 19. Okay, and then n1 dot n2. So then n1 dot n2, which is 3, negative 2, 1, and 3, 3, negative 1. Okay, so 3 times 3 equal to 9. Negative 2 times 3 equal to negative 6. 1 times negative 1 equal to minus 1. So negative 6 minus 1, negative 7. 9 minus 7, 2. Okay, so then theta equal to up cos, okay, n1 dot n2, n1 dot n2 equal to 2 here, divided by absolute values of n1, square root of 14, and absolute values of n2 here, square root of 19. So for this one, use your calculator to get the answer straightly. Okay, straightly going to give you the answers then here, and this give you 82.96 degree. Okay, so we move to the next question then, example. Okay, angle between a line and a plane. So, again, now just imagine that there is a plane and there is a line passing through the plane, which is not a 90 degree, just like we recall the thing that we discussed just now. The line with this angle, something like this. Okay, so then, as we know that the equation of the plane, there is a normal to the plane. Okay, Rn equal to A dot n, where n is a normal to the plane, and there is a line L that passing through the point. Now, from here, which is R dot n equal to A dot n, okay, so, and this n, the normal, is our reference for the plane. This we call n is a reference for the plane. And this L, which is R equal to A plus D and V. So for this straight line, the V is our reference. Okay, so our reference is now is V for this line and N for the plane. Okay. So from diagram, when L and P intersect, A is the angle between the line and the plane. So we are going to find out the angle, okay, cos B, where B is the angle here. Okay, But then we like to find out the angle between the line and the plane, not a line with a normal. Again, we are going to find out the normal, we call the angle between this straight line with the plane, not we call an angle between the line and the normal. But from our recall from our discussion, we call the formula that be given here. From the formula be given here, this one is gonna give you an angle between the we call the vector of the line, okay, the v of the line here and the normal. So in this case, we need to make some adjustment here. Once we get the angle of B, so then we need to find out the angle of A, which is 90 degree minus the angle of B. Okay. So given here, the line of this and the plane. Okay, now, just now, the line of R equal to 2, 3, and negative 1, plus with T and V here is 1, negative 1, and negative 2. Okay, these are here. Okay, these are, I rewrite here, so then it come up with 2 plus T, and then 3 positive times negative is negative, multiplied with T, 2 minus T, and then negative 1 minus 2T. Okay, and then next is the equation of the plane. Okay, this is a line of L and the plane of S. Okay, R dot N equal to A dot N. Given in the question there just now, it is R dot with the plane with the normal, then here is 1, 1, negative 1 equal to A dot N given here equal to 4. So then just imagine that here now, okay, this is a plane and there is a line that from down here, okay, from down here passing through this coordinate at the point of A. Okay, so this is the L. Okay, so now class, this is the normal vector of the plane. Normal vector of the plane. So the normal, we can refer to this one here. This is the normal. And this is the surface of the plane. Okay, and L, we are referring to the V, which is negative 1, negative 1, 1, negative 1, and negative 2 here. So then, the first thing that we're going to do here now is we are going to substitute the equation of a straight line of R here into this equation. Okay, we got 2 plus T, 2 minus T, and negative 1 minus 2T. Okay, so R dot N equal to AN in the equation here is given equal to 4. So R dot N, okay, it is 2 plus T and then 2 minus T and negative 1 minus 2T with N. The normal here is 1, 1, and negative 1, which is equal to 4. So these are from we call in the vector equation here. So we come up with 2 plus 1t, 3 minus 1t here, and 3. It's supposedly 3 here, sorry. Okay, and negative 1 minus 2t. Okay, this is 3. And 2 plus t multiplied with 1 equal to 2 plus t. Three minus t multiplied with 1 plus with 3 minus t, and negative 1 minus 2t multiplied with negative 1. Negative 1 times negative 1 equal to 1. Negative 2t times negative 1 plus 2t equal to 4. Okay. So t minus t equal to 0. Then we got 2t here. 2 plus 3. Okay, 2 plus 3 equal to 5 plus 1 equal to 6. So 6 bring to the side become negative 6. So 2t equal to 4 minus 6 equal to negative 2. Then t equal to negative 1. Okay. So now when t negative 1, we are going to find out the intersection point between the straight line L with the plane of S by substitute the value of t negative 1 here, here, and here. So then, okay, so then R equal to, okay, so then 2 plus negative 1. 2 plus negative 1 for I. 3 minus t j, and minus plus negative 1 minus 2 times negative 1 for k. So then 2 minus 1 equal to 1i. 3 plus 1 equal to 4j, and negative times negative become positive, and negative 1 plus 2 equal to k. Okay, negative I plus 4j plus k. So the position vector of point P. So this is the position vector of point P. Okay. So now, okay, so this is our N, and this is our V. Okay, so now the angle of B equal to cos of N dot V divided by modulus of N and modulus of V. Okay, so what is N and V just now? Where V equal to 1, negative 1, negative 2, where V equal to negative 1, 1, negative 1, and 2. Okay, 1, negative 1, and 2, and N equal to, here, 1, 1, and negative 1. 1, 1, and negative 1. Okay, so we need to find out N dot V. So the N dot V equal to 1, negative 1, and 2 with 1, 1, and negative 1. So then 1 multiplied with 1 is 1, negative 1 times 1 minus 1, 2 times negative 1 minus 2. So negative 3 plus 1, negative 2 then. Okay, I need to make a double check here. Oh yes, 1, negative 1, negative 2. So it's 1, negative 1, negative 2 here. So negative 2, and it's not it. Okay. Negative 1, negative 2 times negative 1 equal to positive 2. So it is 2 here. Okay, and then absolute values of n, the normal of n, equal to square root of the normal 1 square plus 1 square plus negative 1 square equal to square root of 3. And then absolute values of v then, okay, the v is square root of 1, negative 1, negative 2. 1 square plus negative 1 square plus negative 2 square. Okay, so it's square root of 1 plus 1 plus square root negative 2 square equal to 4. That is square root of 6. Okay, so then now the n dot v equal to 2. So angle of B equal to arc cos of n dot v divided by, again, I rewrite everything here again. So absolute values of n, absolute values of v here, we arc cos of n dot v equal to 2 divided by square root of 6 and square root of 3. Okay, use the calculator then to find an answer here. It is 61.87 degree. And class, this is the angle of B. As I mentioned just now, is angle between the straight line V here, using the V as our we call our reference V with the normal of n. Here is a B. So what we want here is the angle between the straight line and the surface of the plane, which is A. So then the angle that we're looking for here, the angle of A equal to 90 degree minus 61.87 degree equal to 28.13 degree. Okay. Next, example 6. Find the parametric equation for a line L passing through the point of A and B, and where does the line intersect the XY plane. So for example 6, okay, so class, just imagine that there is a line L, okay, parametric equation of line L, okay, that passing through the point of A and B. This we call this straight line L passing through the point of A and B. Okay, so that just imagine that there's a we call origin point of O000. Okay, as we know that we discussed this earlier in the subtopic of we call a straight line. Okay, O from O to A plus A to B equal to OB. Okay, from O to A plus A, B equal to OB. And then AB equal to OB minus OA. Okay, we know this, okay, we learned this before. So now class, just imagine that we're going to find out the equation of the line L, as we know that is come out with the equation of R equal to A plus with the scale of T with a direction vector of V. Okay, so in this case, we assume that we can replace or using the coordinate of A, okay, coordinate of A, or this vector of O to A, okay, represent the A here. Okay, now what about V? V, we can use that vector of AB and we substitute here to complete, or for what we call complete, the equation of the straight line. Okay, now here where A equal to 2I plus 4j minus k, from the vector we call from the coordinate given here, where A is 2, 4, negative 1 and B 5, 0, 7. Okay, so again I sketch the, we call the equation, we call the graph again. Here is A and here is B. Okay, and then a vector of V that I mentioned just now. Okay, I did mention just now, where V here we can use that equation of vector of AB. So then equal to AB, which is OB minus OA. So then here we can just simply from A to B, we use the equation where the coordinate of B 5, 0, 7 minus the coordinate of A 2, 4, negative 1. So then 5, 0, 7 minus 2, 4, negative 1. So 5 minus 2 equal to 3, 0 minus 4, negative 4, 7 minus negative, negative become positive, so 7 plus 1 equal to 8. Okay, so V in this case equal to 3I minus 4j plus 8k. So the vector equation, which is R equal to A, where A is 2, 4, negative 1 plus with T, scalar of T, and V is 3, negative 4, and 8. Okay, so now the parametric equation, in parametric equation, R is X, Y, and Z. So then X, okay, X equal to 2 plus 3t, 2 plus 3t. Y equal to 4 minus 4t. And then Z equal to negative 1 plus 8t. Okay. And then the line, this straight line intersect at the xy plane. There's a plane of xy at the point of where z equal to 0. So when this, okay, where does the line intersect the xy plane? Okay, intersect when z equal to 0, because we're talking about the plane on the x and y axis. Okay, so then z equal to 0, the line intersect the xy plane. So at point of z equal to 0. So when z equal to 0, so look at this one here, negative 1 plus 8t equal to 0. Negative 1 plus 8t equal to 0. So from here we get t equal to 1 over 8. So when t is 1 over 8, we are going to substitute here and here to find the value of x, y, where z equal to 0. Okay. So when when t equal to 1 over 8, so then y equal to 4 minus 4t, which 1 over 8. And this one is going to give you x. We should come up with x first, okay? Where x equal to 2 plus 3, 1 over 8. Okay, 2 plus 3t, 4 minus 4t. Okay, so x first, this is going to give you 19 over 8. And for y, it is 7 over 2. So the final answer here, the line intersect, okay, the xy plane at the point of 19 over 8, 7 over 2, and z equal to 0. Okay, so class, the rest of it is all the exercise, which I think that I'm not going to explain to you everything, all the questions in this we call lecture notes. So I do hope that all of you, okay, try a few questions from here. Exercise 1, 2, and 3 by yourself. Okay. Okay, try the question by yourself, and my colleague. Okay, so these are equally called the conclusion for overall of the discussion for this video. Okay, you can just refer to your lecture notes, all this. So my colleague, Mr. Rodri, had also prepared an extra videos. If you can just click to this link or copy up this link and watch by yourself all the videos that been provided by my colleagues. Hopefully it helps you to understand that the whole content of this in this topic here. Okay, so that's all for today. Thank you very much. Till we meet again. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day. That's all.